Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to do our last set of notes of Section 2, Chapter 4, Solving Systems of Equations by Substitution. Specifically, our focus today is going to be on equations that result in no solution or infinitely many solutions. So let's take a look at some of our examples. So our first problem is number 1, says y equals 3x plus 1 and 6x minus 2y equals negative 2. We're going to solve this system using the same process we've been using all week. We're going to take what y equals, the 3x plus 1, and we're going to plug that into the other equation. Specifically, we're plugging in for y because it's what y equaled. So I'm going to have my equation 6x minus 2, but instead of y, I'm going to replace from the first equation the 3x plus 1, and that equals negative 2. Once I have my equation set up, I'm going to solve the equation. So I'm going to distribute the negative 2, so 6x minus 6x minus 2 equals negative 2. And then I'm going to combine my like terms. 6x minus 6x is going to cancel out completely. So I'm going to be left with negative 2 equals negative 2. When your variables cancel out completely, you need to look at the statement left and ask yourself if it's a true or a false statement. Negative 2 is the same as negative 2, so this would be a true statement. And when you're left with a true statement, we call this infinitely many solutions. So the variables are completely gone. You're left with same number on left and right. The answer is infinitely many solutions. Taking a look at number 2. Number 2 says y equals 3x minus 11 and y minus 3x equals negative 13. I'm going to move this up a little bit so that one can become our focus. And we're going to solve this equation same way we've been solving systems all week. I'm going to use the equation that says y equals 3x minus 11. And I'm going to plug the 3x minus 11 into the other equation. Specifically, I'm plugging it in for y because it's what y equaled. So I have 3x minus 11 minus 3x equals negative 13. I'm going to combine my like terms. 3x minus 3x is going to cancel out, so I'm left with negative 11 equals negative 13. When my variables cancel out completely, look at what's left and ask yourself if it is a true or a false statement. Negative 11 is not equal to negative 13. This is a false statement. So since these are not the same number on left and right, they are not equal to each other, this one would be called no solution. So if a false statement occurs after all the variables have canceled out of the problem, we call that no solution. So let's take a look at number 3. Number 3, we have 5x minus y equals negative 4 and y equals 5x minus 4. I'm going to take the second equation where y equals 5x minus 4, and I'm going to plug that into the first equation. Specifically, I'm plugging it in for y. So I'm going to have 5x minus, the y is going to be replaced with 5x minus 4, and that equals negative 4. I'm going to solve this equation by distributing the negative. So this will be 5x minus 5x minus negative 4 would become plus 4 equals negative 4. Combine my like terms. The 5x's are going to cancel out since I'm subtracting them, and I'm left with 4 equals negative 4. Now, since my variables canceled out completely, I'm asking myself, is 4 the same thing as negative 4? Well, no, it's not. So this would be no solution. And lastly, number 4. X plus y equals negative 4 and y equals negative x plus 5. I'm going to use the equation that already has a variable by itself, and I'm going to plug in negative x plus 5 into the first equation. Specifically, I'm plugging it in for y because this was a y equals equation. So I'm going to have x plus negative x plus 5 equal to negative 4. I'm going to simplify. X plus negative x could just be minus x. Plus 5 would be plus 5 equals negative 4. X minus x will cancel out, so I have 5 equals negative 4. Since 5 is not equal to negative 4, it's not the same thing, this one is also no solution. So this concludes our lesson on being able to solve equations that result in no solution or infinitely many solutions. If you have any questions, please ask Miss Brooks. Otherwise, I'll catch you next time on your Daily Dose of Math with Miss Brooks.